Hi guys, this is my video demonstration of Pickey bot. So as in the instructions, first we have to power on the 9-volt rail, then we will power on the 5-volt rail. Now the robot has started, then the Wi-Fi should have started by now. Now we'll have to connect to the Wi-Fi. So let's go to Pickey. Now we have, this is my Ubuntu virtual machine, as you can see, and in the Ubuntu virtual machine, in the Linux terminal, this is the Linux command line interface. I am running the Python code. Now I will show you that I can control it with individual commands from the command line interface. So if I type in the command motor 1 with speed 10, it will start rotating. And if I set it to 0, motor 1 0, it will stop. And but controlling a car like this is difficult, right? So to make it more easier, I use a graphical user interface like this. So now I can just press the relevant buttons that I have pre-programmed in the controller.py code, and control the robot very easily, and it turns around and you can control the arms. The arms are a bit laggy because I programmed it to only rotate 1 degree uh, per command, because to make the rotations more smooth and more accurate, because that is what I'm going to use to pick up the items, right? And now, as in the demonstration, I'm going to pick up that key over there. So I'm going to move this out of the way, and I'm going to use the ultrasonic sensor to identify that I'm in good range for the pickup. So when I move it back, I'll reduce the speed first. From here you can see the speed of the motor. I'll reduce the speed to 1, and when the buzzer beeps, that's when I know that I have gone too close to the object. I have to go front a little and pick up the object. So I am waiting for the beeping sound. Yeah, there we go. So now I'm too close to the object, so I'm gonna slowly move forward a little until the beeping stops. Okay, the beeping stopped. Now I can safely lower the arm and try to pick up the object. Oh, come on. Okay, it timed out again. When the servo gets stuck, the Wi-Fi tends to time when the servo gets stuck. So you have to be careful not to uh, push too much. When the servo feels stuck and it's not moving, you have to stop trying to move the servo, or else the Wi-Fi gets overloaded and might time out. Hi. So the last video was cut off because the device keep timing out every time the servo gets stuck. I found the reason for that. That is, the when the servo gets stuck, they draw a lot of current, maybe up to 1 amperes. So what happens is it drops the voltage between the 5 volt line and doesn't give enough voltage to the two ESP32 boards, and they turn off. So what I did was just a quick fix. I added three 1000 microfarad or 1000 microfarad capacitors across the 5 volt line, and now uh, even even when the servos gets very stuck, even when the servos get stuck, the power remains uh, the power remains stable and the ESP32s do not time out. Okay, back to the video. So I was demonstrating how I could pick up the key. I'll try to pick it up once again. And that is how you can use Pickey to pick up an object. I know it was a drag, but I learned what happens when servos get stuck. That's a win. Okay, and to give you another demonstration of what I have done, uh, in in the documentation I have explained how I have used the uh, INO files to only transfer the code given by the Python script straight to the slave, and in the slave INO file, in the slave INO file, all it does is handles the given command to it. It does not care about running 4 servers at once. It doesn't care about running 4 motors at once. All it does is when I give it a command, it runs a new command. So what I have essentially done is I have applied a layer of abstraction on the hardware. So when I give a command from the Python script, it straight up runs. It's just an abstraction. So because of that, now I can edit something like this. This is the code to do a half turn, move only these wheels forward to do a half turn to the left. So I can just add that code to the control.py. I don't have to edit anything in the INO files or the ESP32s. I just have to update the code, uh, run the script again, and the new command will work. I added this button for that. It works. So I think this is a very successful project on my terms because it works from the Linux terminal. It solves a real life problem, picking up stuff that's hard to reach, and it looks cool as well. So thank you for marking this. Hi, this is a video of Pickey actually picking up a object under a bed.